Okay, so this is Chapter 3, Section 2, Solving Linear Equations by Graphing. So just as always, I'm going to start off with my little screen tutorial here. So this is the way the homework will look like when you first open it on Alex, with the exception of a couple of things. You will see a due date on your screen. I do not see one on the teacher preview because it's not actually due for me, but you will see one here before attempts. On attempts, you will always see the number of attempt that you're on. So I'm on number 1 and unlimited attempts. This means I can submit this assignment as many times as I would like, and I get to come right back in and try it again. Doesn't take away any problems that I get correct. It only gives me problems that I have not answered or that I have already gotten incorrect at one point. This one has 3 questions on it. So all the assignments will have anywhere from 1 to 10 questions, kind of depends on what was available for us to choose when we created this. And then grading policy was best score, so that means whichever attempt is the best one is the one I get to keep. And partial credit is enabled, meaning if I answer 1 of 3 questions, I get credit for my 1 question. And then this one is just a warning, once you've started your homework, you must finish it before you can work on anything else. What that means is when I click on Start here, now I've started my homework, and on your screen, you should see a Submit Assignment button down here in the bottom right corner. Again, I don't see that on the teacher preview, but you will see it on your screen. You always, always, always click that Submit button, because if you don't, it will lock you out of every other assignment. You will have to come back to this one. But if you click Submit Assignment, remember unlimited retakes or unlimited attempts, so you can come back in and keep trying over and over again. So if you answer question number 1 and then you want to come back and do 2 and 3 later, that's fine. Click Submit and come back. Don't just close the screen. I can't stress how important that is. All right. So for these 3 buttons on the side, you will always see these 3 buttons, with the exception of the calculator here, and sometimes the calculator, I'll say it that way. The explanation button tells you you're going to lose your attempt on this question because it's going to quite literally give you the solution and answer to this question you're looking at, not an example, this one. So it's not going to give you the answer and then, have you come back in and type it. But it is a very nice feature because maybe you've looked at the example, you understand the example, but you don't quite understand the way this problem is written. So you can actually see a solution to the problem you're looking at instead of just a general example, and you just come back in on another attempt to get the points for it. Example just quite literally opens up another screen here, or a pop-up screen, and it shows you an example of the problem type that you're looking at. There we go. It's just taking a minute to load here. So it's showing us how the program wants us to solve it, and you can close this when you're done. You can click here for another example, and it'll keep giving you a different example each time. And then there's also the message center, so that you can message directly to your teacher, and then your teacher knows exactly where to go to help you with that question. Okay, so we're going to go ahead and review some graphing that we just did in the last section, and we're also going to start introducing the idea of finding solutions to our linear equations. So just like we did in the last section, we're given an equation. So here's an equation, 3x minus 1 equals 8. This one's a little different because I don't see a y, and I'm going to explain that in just a second, because we do have an x-y coordinate grid here, so I know I have both. And it's this graph, draw a graph to help solve the equation, then find the solution to the equation. So in this situation, what we want to do is we want to take this guy, and we want to make it equal 0, meaning I want to move everything to one side of the equation. So 8's all by itself, I'm going to move it over to this side. So now I have 3x, negative 1 minus 8, that's negative 9. Remember, I had negative 1 and I went 8 more negative. Positive 8 minus 8, that cancels out down to 0. So this can also be rewritten as y. And what this is doing, and if you remember the section or the problem that we had in the last section where we were finding x and y intercepts, if I make y equal 0 and I solve, that is my x-intercept. So they kind of already did this, and there was a partial solution a little bit here where the 8 was moved over. But we want to have a little bit more than just the x-intercept because they want us to graph it. I need more than just one point. And remember, the x-intercept is a single point. So that's why we want to do this, so that I can have a little xy table like this, and I can actually solve this. And 3x minus 9, which is the expression that y equals, will go in the middle there. So now I'm going to choose some values for x, and I'm going to solve. So 3 times 0 minus 9, well, 3 times 0 is going to be 0, because anything times 0 is 0. Minus 9, that's going to be negative 9. 3 times 1 minus 9, so that's 3, because 3 times 1 is 3. Minus 9, well, that's going to be negative 6, because they're opposites, so I subtract. And then 3 times 2 minus 9, so that gives me 6 here. 3 times 2 is 6, minus 9 is negative 3. So now I want to go through and I want to graph these really quick. Let's see, we have 0 and negative 9. And then we have 1 and negative 6. And we have 2 and negative 3. So those look pretty linear to me, meaning they're in a line. And perfect, they all line up. So what I'm looking for, the solution to my equation is where it crosses the x-axis. It's actually the x-intercept. That's what I want. So now that I have it graphed, I can follow this up and go, okay, it crosses right here at 3. So I have x equals 3. And that is my solution. If I would have continued to solve this original equation they gave me, like this, because since y isn't there, what it means is y equals 0. That's what we've put in there. So if I continue to solve this, I will arrive at that exact same answer. 3x drops down, x minus x cancels. 8 plus 1 is 9. I divide by 3 to undo that multiplication there. X equals 3. Look at that. I have x equals 3. I have x equals 3. So I can kind of check that really quick, make sure that I did the graphing correctly. But we want to make sure we kind of move this around so that it equals 0. And then set up our xy table so that we can actually graph the problem here, or graph the equation. All right, let's go ahead and click check and move to the next piece. All right. And so we're going to do something very similar on this next one here. So we have 1 minus 2x equals negative 5. So same thing, I'm going to make this equal 0. So 1 plus 5 is 6 minus 2x equals 0 because negative 5 plus 5 cancels out. Remember, this is the same thing as y. I want to know what my solution is, so I need to make y equals 0 in order to do that. So now we have x, y, and our expression is 6 minus 2x. So 0, 1, 2, because those are the numbers I always seem to like. So we're going to plug in 0 here. So anything times 0 is 0, so the only thing I'm left with is 6. 6 minus 2 times 1. So negative 2 times 1 is negative 2. 6 minus 2 is 4. And then 6 times 2 times 2. So negative 2 times 2 is negative 4. 6 minus 4 is 2. All right, so we have 0 and positive 6. And then we have 1 and positive 4. And then we have 2 and positive 2. So again, those look pretty linear to me, meaning they're in a nice straight line. And perfect, that works. So I want to come down here and go, okay, it crosses. And by chance, again, it crosses at 3. That's just coincidental. It's not always going to be 3. For whatever reason, that's what these two examples worked out to be. All right, perfect. We are going to try one more of these guys, and then we will be all done with this. So we're going to do the exact same thing. Negative 2x plus 3 equals negative 3. And we're going to make this equal 0. So we're going to add 3 to both sides, so those cancel, and I get negative 2x plus 6 equals 0. So remember, this is also y. So I'm going to go x, y, negative 2x plus 6, 0, 1, 2. Again, you can choose any numbers you would like in there. I always tend to choose 0, 1, and 2 unless I have a fraction and I want to eliminate that fraction. I'll use something that has to do with the denominator. But normally I choose 0, 1, and 2 because they're easy to plug in. You want to make sure you're using numbers that will be on the grid as well. So if you use big numbers, it doesn't actually mean you're wrong as far as the coordinate. But if you can't graph it on the shown grid, the coordinate grid or coordinate plane that they give you here, then it won't let you use it. So, just be careful with big numbers because you may end up getting the x and the y as far as the coordinate, but you can't graph it. All right, so negative 2 times 0 is 0, plus 6 is 6. Negative 2 times 1 plus 6. So negative 2 times 1 is negative 2, plus 6 is 4. And negative 2 times 2 plus 6 is negative 4 plus 6 is 2. So this ended up being exactly like the last one. So I believe those were even the exact same points as the last one. So we end up with 0 and 6, 1 and 4, and 2 and 2. So by chance, we ended up with the exact same ones, and we end up with x equals 3 again. So that's not always going to happen, but for whatever reason, they kind of give us very similar examples here, or very similar problems. All right, so that was section 2, and I will see you in section 3.